Hello, welcome to your section 6.2 video. This is a hard section to kind of summarize and do in a couple quick points, and so what I'm hoping is this. I'm hoping you've looked at these problems and have made a really solid attempt at them before watching this video. If not, go ahead and just pause or even turn it off, go do these problems, there's only 6 of them, make a really good attempt at them, and then come back and then watch the video because I'm going to be explaining how to do these problems. But as you know, if you don't struggle through the math, you're not really going to be able to learn it. It's so easy when I'm doing it because I know exactly what I'm doing. I'm like a professional at this. So make sure you put in a good effort, struggle with them a little, and then you can see how you do. All right, so I'm just going to be doing some problems out of the book. We'll start with number 5. And in each of these problems, we're looking at simplifying. Simplifying meaning we want to get the like terms together, and we want as many things from under radicals to be outside of the radicals. So we kind of need to apply different rules and different techniques to every single individual problem. For example, let's take a look at number 5. Now, let's look at the features of this problem. First of all, something that I see is that there are different bases. Therefore, this is not a situation where I'm allowed to kind of combine the bases and add the exponents because these bases are different. However, I do notice that the exponent is the same. And so a rule that I can apply is I can multiply the bases and write them under the exponent of 1/4. So let's do that. 3 times 27 is 81, and that's 81 to the 1/4. That's a mathematical rule that I'm allowed to use. And don't forget that 81 to the 1/4 is the same as the 4th root of 81. And so actually, a way you may have seen this rule before is this. If I had 4th root of 3 times 4th root of 27, you may be comfortable recognizing that if there are two numbers under the same root, I'm allowed to multiply those two numbers to combine them. So at this point, I'm trying to get the 4th root of 81. In other words, I'm thinking what number times itself 4 times gives me 81. I am expecting you to do this without a calculator. If you can't figure it out just kind of by guessing and checking, use a strategy. Break 81 down. 81 is 9 times 9. 9 is 3 times 3. So notice that 81 is 3 times 3 times 3 times 3. In other words, 3 times itself 4 times gives me 81, which means the answer to this problem is simply 3. Not too bad. Unlike my voice is terrible right now. And I am struggling to produce these videos, yet I soldier on for the joy of learning. Let's do another similar type of problem. I have the 4th root of 8 times the 4th root of 8. Now, what we could do right away is, in a similar vein to the last problem, I could multiply these together, put 4th root of 64, right? 8 times 8 is 64, and I'm allowed to combine them because they have the same root. However, I am going to need to break down the 64 eventually to figure out if I can pull things out of this 4th root. Wouldn't it be easier to break down the numbers before I multiply? That's the technique I want to use here. Let's break down these 8s before I combine them. So this 8 is 4 times 2. In other words, 8 is 2 times 2 times 2. Same with this 8, 4 times 2. So this 8 is 2 times 2 times 2. So here's what I'm going to do. Instead of writing the 4th root of 64, let's write the 4th root of 2 times 2 times 2 times 2 times 2 times 2. And that is exactly what I would get if I had multiplied to get 64 and then broken down 64. I know a lot of people like multiplying and then breaking down, but really, when you can break down before you multiply, why would you bother? Now, don't forget, the 4th root means I'm looking for something that multiplied times itself 4 times. So take a look here. Here are 4 2's. Since there are 4 of them, I know that the 4th root of 2 times 2 times 2 times 2 is just 2. So that 2 is going to end up being outside of the radical because the fourth root of 2 times 2 times 2 times 2 is just 2. What's left inside the radical, though, are these 2 times 2. There are not 4 of them. Therefore, they get left under the radical, and this is my final answer. So 2 times the fourth root of 4. All right, let's take a look at the next problem. Next problem is number 26. Number 26, we have another similar one. Cube root of 108 times cube root of 4. Now again, what you could do is you could start by multiplying 108 times 4. Why bother though? Because you're going to need to break them down eventually anyway. Take a look at what I'll do. Let's break this 108 down first. 108 is 12 times 9. 12 is 4 times 3. 9 is 3 times 3. And finally 4 is 2 times 2. 4 is just 2 times 2. Since I'm multiplying these things together, I'm going to get the cube root of all of these numbers multiplied together. That's if you're counting 4 2s and 3 3s. Now, since I have a cube root, I'm looking to see if there are numbers that are multiplying times themselves 3 times. Here, I see 2 times 2 times 2. The cube root of 2 times 2 times 2 is simply 2. Also here, I have the cube root of 3 times 3 times 3. Obviously, the cube root of that is 3. So outside my radical, I have a 2. I'm multiplying that by 3. What's left under the radical is this guy. He is not involved in a triple, so he has to stay under the cube root. And of course, let's just multiply the 2 times 3 to get 6. So 6 times the cube root of 2. All right, moving right along to the next problem. We need to do number 38 next. Number 38 is undoubtedly a fun one. 12 times the fourth root of 2 minus 7 times the fourth root of 5, 12. Now, remember, if I have a subtraction sign, I can only subtract if I have like terms. Right now, since this is the fourth root of 2, but this is the fourth root of 512, I do not have like terms, so I cannot subtract them. However, even though this fourth root is fully simplified, this fourth root is not fully simplified. So let's see if we can simplify this fourth root at all. I will factor out 512. It happens to be 256 times 2. And 256 is 128 times 2. And it looks like I'm doing powers of 2 here. So this is 64 times 2. This is 2 times 32. This is 2 times 16. I know in this 16 there are going to be 4 more 2's. I just kind of know that. Like, you can continue to break it down, but I know there will be 4 more 2's. So this 512 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 2's. All of those 2's. And remember, I'm looking for if there are quadruples of them. So here's a quadruple. The fourth root of 2 to the fourth is just 2, right? The fourth root of 2 times 2 times 2 times 2 is just 2. Here is another quadruple. So I'll get another 2 outside. And then this 2 will be left under. So let's summarize what I did there. I didn't mess at all with the first term, but this second term, now outside I have this 2, I have this 2, and 1, 2 is left under the fourth root. So let's simplify things. 12 fourth root of 2, still not doing anything to that first term, but here 7 times 2 times 2 is 28. So 28 times the fourth root of 2. Look, now I have like terms. Both of these terms have a fourth root of 2. So just like 12x minus 28x would be negative 16x, here 12 times the fourth root of 2 minus 28 times the fourth root of 2 is going to be negative 16 times the fourth root of 2. And I made my 6 very badly, so let me try to correct that. Much better. All right, great. All right, we're moving next to number 15. I know this video is getting long, but I'm sorry about that. It's just these provide long explanations, like it's just necessary. With number 50, we have a big complicated fraction. However, there are some very easy things I can do right away. For example, at the bottom, the square root of 25 is 5, and the square root of x to the 16 is x to the 8th. The reason being that there are, within the x to the 16 different x's. That means there are 8 pairs of x's, and the square root of each pair of x's is just x. So the square root of x to the 16 is x to the 8th. The cube root of x has no x's that can come out since there's not a triple of x, but the square root of x to the 5th, there are 2 pairs that can come out, so x squared, and that will leave me with 1x under the square root. Now, I see some things that can cancel here. For example, there are 2 x's on the top and 8 on the bottom, so that'll leave me with just 6 on the bottom. Also, rather than writing the cube root of x as that, let's write it as x to the 1/3, and let's write the square root of x as x to the 1/2. Because if I think if I write things this way, I might in fact be able to kind of see what's going on with these problems. And the thing that's going on with these problems is that I have the same base and different exponents. So the exponents are going to add. 1/3 plus 1/2 happens to be 5/6. So I can say here x to the 5/6 over 5x to the 6th. Now, probably there are a couple different ways you could simplify from here. I think that I would just like to subtract these exponents. Since there are 5/6 of an x on top, let's go ahead and subtract the exponents. 6 minus 5/6 is going to be, I think that'll be 5 1/6, which will be 31/6. So this is a possible way you could simplify it. There are a couple other different ways of simplifying it, but that's a possibility that I happen to like. You know what though, in thinking more about number 50, I'm thinking maybe we should just leave it at this step. And the reason I think that maybe we should leave it at this step is because a fractional exponent kind of indicates that there's a root going on, and we're really not supposed to have roots on the bottom of fractions. So I think if we leave it here, that means that there would be a root on the top of the fraction. In other words, instead of writing 5/6, I could write the 6th root of x to the 5th. Now there's a root on top and not on the bottom, so let's keep it that way. And the reason I wanted to keep it that way is so that it's consistent with what I'm going to tell you to do in 56. 56, we have a 5th root on the bottom. Now, since it's x to the 6th, that means that I can pull out 5 of those x's, right? I'm looking for something that multiplies times itself 5 times. So I have 5 x's within that 6, so I'm going to pull out an x. That leaves me with the 5th root of x. Do you see what happened there? 5 of them, the 5th root of 5 of them are x, and there was 1 x left over. Now the issue is, at this point, I have a root on the bottom of a fraction, and I really don't want that. So let's think about how I could cancel this root. I'm going to need to multiply by something on the top and the bottom, the 5th root of something. And the somethings need to be the same so that I'm only multiplying by 1. So when I just had square roots, I could just multiply by exactly what was under the 5th root. The issue is this. Here, if I have the 5th root of x times the 5th root of x, that's still only the 5th root of x squared. And I haven't gotten up to where there are 5 x's so that the 5th root will cancel. So instead of just multiplying by the 5th root of x, which will only give me x squared, which doesn't cancel the 5th root of x, let's multiply by the 5th root of x to the 4th. Now, how did I choose x to the 4th? Let's think about this. If I have the 5th root of x times the 5th root of x to the 4th, how many x's are now under the 5th root? And the answer is that there are 5 of them. And if I have 5 x's under the 5th root, that means that I am left with just x. So I have this x, and I have this x. So in other words, I now have x squared on the bottom. On the top, there's no simplification I can do, just -3 times the 5th root of x to the 4th. It looks ugly, but that happens to be the correct answer. Hey, I'm sorry for the hoarseness of my voice. I'm sorry for the length of this video, but I hope kind of working through these examples helped you. It's a hard section to teach because there are so many different rules. I can't tell you just, hey, do this all the time. You really have to have some good mental flexibility for it, but hopefully this helped. Thanks. Bye.